As we have seen, a compass will indicate the direction to magnetic north by detecting the Earth's magnetic field. The Earth's magnetic field has a vertical element as well as a horizontal element, as depicted in the diagram. The nearer to the magnetic pole, then the greater the vertical component becomes, and the less the horizontal component becomes. Eventually, at the pole, the vertical element becomes 90 degrees, due to the magnetic pole being directly below the position. The angle that the magnetic lines of force make to the horizontal is referred to as the angle of dip. This angle will be maximum at the magnetic poles and reduce as we move away from the poles. Approximately halfway between both magnetic poles, the angle of dip will be 0, as the component is all horizontal, and the vertical element is nil. The position where this occurs is referred to as the magnetic equator. It is undesirable for a compass system to be influenced by the vertical element of the Earth's magnetic field, as this can induce errors. The horizontal element is used by the compass to determine magnetic north, and this is known as directive force. As can be seen in the diagram, the angle of dip will vary with increasing magnetic latitude. Example A has a low dip angle, as it is near to the magnetic equator. Example B has more dip at mid-latitudes, although the angle is acceptable. Example C has a large angle of dip, as it is near to the magnetic pole. The angle of dip is referred to as inclination, and the line of zero dip, the magnetic equator, is referred to as an aclinic line. The magnetic equator can be seen in the image on screen, together with lines of inclination over the Earth. Magnetic field strength is measured in microteslas. A general requirement for most compass systems is a field strength of at least 6 microteslas. The image seen here depicts the area around the North Pole, where the vertical element of the Earth's magnetic field is high, and the directive force can be below the 6 microteslas threshold. Compass systems generally use a method of pendulous suspension that ensures that the magnetic detector is as horizontal as possible, and is therefore more effective in sensing the horizontal component. This is discussed in more detail later.